Welcome everyone to section 12.1 surface areas. This is actually the start of chapter 12. Now going into chapter 12, we ended with like circles, and we came up with a surface area of a circle. We came up with the volume of the circle, and that's kind of the same thing we're going to do, but we're going to apply it to a much broader base of different shapes. So we're going to start off kind of where we started off with circles, and we're going to start off with just surface area. Now, if you remember from surface area is just how much paint it takes to kind of cover a circle. So you're not going to figure out how much paint it takes to fill up. So picture painting a room. You don't need to calculate how much paint you need to fill the room. You just need to kind of calculate the paint that you need to put on the left wall, right wall, front wall, back wall. If you're painting the ceiling, maybe the ceiling as well. So when we're talking about surface areas of these three-dimensional objects, we're just thinking about what it says here, a two-dimensional measurement of the surface of the solid area. In other words, we're really just going to get the area of the parts. So rather than thinking of surface area on the whole thing, we're actually going to break it apart into parts, and we're going to find the area of the parts. So when we look at this first example, it says determine the surface area of this, pentagonal prism. Pentagonal means we have 5 sides, and we're talking about pentagonal prism. What we're actually doing is we're looking at a pentagon that just gets extended into a 3-dimensional shape. So rather than just having a pentagon, it's going to drop down. It's going to have a base that's also a pentagon. So when we're talking about prisms, it's basically going to be some kind of polygon on top and bottom. And we'll get into more descriptions down below. So we have a pentagonal prism, and we're supposed to find the surface area of this pentagonal prism. So once again, we aren't looking at how much it would take to fill this entire thing. We're looking at how much paint would it take to paint that? How much paint would it take to paint that? How much to do that? To do the top, to do the back ones and the bottom. How much paint would I actually need to cover that entire surface? So rather than treating it as a 3-dimensional object, as we see here, what we typically do is we redraw it, or at least we repicture it. And what we have here is we have a pentagon right here that represents that pentagon on top. Moving on, we have a pentagon right here that represents the pentagon that's on the bottom. And if we look around here, we have 1, 2, 3, 4, 5 sides. So you're going to see we have 1, 2, 3, 4, 5 sides accounted for. So this is a 2-dimensional representation of our 3-dimensional shape. All the parts that make up our 3-dimensional shape, we draw it as such. This is known as a net. A net drawing or a net structure. You'll actually see online, let me change that net so it's a little clearer. You can actually find like resources where you can actually buy these, where you can build these shapes up and break them down into the net. Now, how you draw this net isn't really that important to this class. What you need to just recognize is that we have 2 pentagons, and we have 1, 2, 3, 4, 5 rectangles. That's really what amounts to this net, that I want to see what different shapes make up this 3-dimensional object. If you draw it differently, awesome, but this is typically how you draw a net when someone asks you to draw a net. Okay, so we're supposed to find the surface area of this 3-dimensional shape, which the first thing we do is we decide how many shapes make this up. So we're going to start off with this pentagon. We're going to say, well, guess what? We have 2 pentagons. We have 1 pentagon, 2 pentagons. So when I'm looking for the area, the surface area of the shape, the first thing I'm going to do is I'm going to find the surface area of my 2 pentagons. So all we're going to do is we're going to go, okay, 2 times, and we're going to multiply by the area of a pentagon. Now, just as a reminder, any polygon, if I'm looking for the area of it, it is going to be 1/2 the apothem, 1/2 times the apothem times the perimeter. Just remember, for perimeter, that is just how many sides you have times the length of your side. Your apothem, just as a reminder, if you have any kind of shape let's apply it to maybe a six-sided figure. Your apothem is that length that goes from one side to the center of the circle. That is your apothem. Let's erase that. Okay, and like I said, for perimeter, that is length of your side times your number of sides. So number of sides times length. Well, let's see if we have all that information. Let's bring that 2 out front. So it's 2 times 1/2, so those are really going to cancel out, but let's just leave it in for our notes. So we'll go 1/2 times our apothem. If we look down here, our apothem is actually this line right here. Ooh, I almost circled the 16. I don't want to do that. I want to circle this line right here, which says that it's 11 centimeters. So the apothem of either one of these, maybe I'll even draw it in here, where we draw a little line up here, is that 11. And that comes from here. So our apothem is 11. Now our perimeter, remember it is the number of sides times the length. Well, the length of the side is that 16, so each of these are going to be 16, that's a 12, 16, and that comes from this 16 down here. And a pentagon has 5 sides. So when I'm looking for the perimeter, we have a number of sides, we have 5, and we multiply that by 16. That is the perimeter. Now when I plug that in my calculator, 2 times 1/2, that just cancels out. So it's really 11 times 5 times 16. And if you do that math, you should come out to 180 centimeters. All right, and since it is area, it's going to be centimeters squared. Now that is the area of both our pentagons. Now we have to find the area of our 1, 2, 3, 4, 5 rectangles. So we're going to find the area of 5 rectangles. Well, that's just going to be, 5 times the area of a rectangle is just length times width, which in this case would be 5 times, well, if we look at our drawing, our length or width or whatever you call it is going to be 23 by 16. That 23 comes from here, that is the height. And this 16 right there will be the base of every single rectangle. Note, these are all regular rectangles, so every single rectangle must be the same size. So when we're looking at these, we're looking at, maybe I'll draw it on here, we have 16 by 23. So that'll be 5 times 16 times 23, which is going to come out to 1,840 centimeters squared. Well, that means our total surface area, let's call it S dot A, is going to equal our 2 pentagons plus our 5 rectangles, which would be 880 plus our 1840, which is going to come out to 2,720 centimeters squared. So when we're looking at surface areas of a 3-dimensional shape, really the hardest part you're going to find is what sides do you have? What shapes make up this entire big shape? How do I look at this 2-dimensionally? It doesn't seem that bad right now when we're just talking about a pentagonal prism. But when we start having things that have like holes that go through it or missing parts, that's when it starts getting a little more difficult. Your job, once again, is just to ultimately, what I'd love to see you do is draw pictures of every single shape that makes up this bigger shape. That's going to be the easiest for you, rather than just kind of plugging in your calculator and hope that you're getting the right shapes. Particularly when you get to the test, the better organized you have, the more points I'm going to award. So if we look here, I drew a picture of my pentagons. I drew a picture of my rectangles. I showed right here that I was finding the area of my 2 pentagons. I showed that I was finding the area of the 5 rectangles. That way, say I forgot this too, I would know, grading it, that you forgot that too. If you just plug everything in your calculator and you just have a little scratch work down and all of a sudden you come out to 1,500 or something, you're going to lose a ton of points because I don't know where that came from. So in your homework, I highly suggest you break down the pictures and show each individual area that you are finding. So once again, I wrote 2 pentagons, 5 rectangles, add them together. That way, if you make a mistake, I know exactly where it is. So moving on, determine the surface area of a cylinder. Well, note a cylinder. So a cylinder, easy enough. We do have 2 circles. We have a circle from the top. That's a square, I'm pretty sure. Let's switch that to circle. So we have a circle on top, and we have a circle on bottom. Now, just like if you roll up a sheet of paper, if you roll up a sheet of paper, the top has a circle and the bottom has a circle as well. But when you unroll that sheet, you have a rectangle. So the net drawing of this is going to look something like this, where we have a circle on top, a circle on bottom, and a rectangle. Now I'm going to note with the circles, they do give us some information about the circle. They tell us that our radius is 6. And they also give us the height of the rectangle is 15, and those are centimeters. So when I'm determining the surface area of the cylinder, I need to find the surface area of the 2 circles, and I need to find the surface area of the rectangle. Well, the circle should be easy enough. We're doing 2 circles. Like I said, keep things organized. I'm going to change that 2 to a red color because it's 2 circles, so it's 2 times the area of a circle. Remember, your area of your circle is pi r squared. So pi times the radius, which in this case is 6, squared. That'll be 36 times 2, which is going to equal 72. Don't forget about the pi. And this would also be centimeters squared. Cool. All right, so that is my 2 circles. Now we have 1 rectangle. Now the rectangle is slightly harder to kind of picture what we're doing. So we have length times width. Length times width is easy to start off with because we have this 15. That is the height of the rectangle. In other words, this red bar matches that red bar right there. However, the harder part comes with the kind of width of the triangle. Think of our width as being that green line. Well, the width of that green line also matches with this green line that I'm showing right here. It is that, like I said, if you wrap up a sheet of paper, your width is what wraps around that circle. So the thing you need to recognize is that is actually the circumference of the circle. Our circumference of our circle is 2 pi r, which in this case would be 2 pi times 6. That is your circumference of your circle. Which is probably the hardest part of our cylinder to remember, that is your circumference of your circle. So everything was given to us. They gave us the width by giving us the radius of the circle. So one rectangle is going to be its height, which was 15, times the circumference of the circle, which is 2 times 6, which is 12 pi, which is going to come out to 180 pi centimeters squared. Cool. That means our surface area, SA, is just going to equal that 72 pi plus that 180, excuse me, pi, which is going to come out to 252 pi centimeters squared. So once again, I think the hardest part about a cylinder is just recognizing that the width of the circle or the rectangle is your circumference. Circumference is the big thing on that one. Otherwise, it feels like it didn't give you enough information. All right, sliding on. Now we're going to talk about the surface area of a cone. The good thing about a cone is it really is 2 shapes. We have this circle that's on the bottom. Well, that's nice because really we just have radius on it. So the important thing about that circle is that 9 centimeters. If I was asking to find the area of that circle, we would just go, okay, pi r squared. The more difficult part is kind of this cone shape. So this cone shape, it's going to look almost the same. Let's change that to black. Let me redraw that. So that's kind of our 2D representation of that cone. There's no really good way to draw. Just recognize that this is 3D, and this is it opened up into kind of a 2D shape. Think of that as being a flat shape. It's got no depth to it. Like I said, it's hard to kind of draw and picture it unless I had a sheet of paper, but obviously right here I cannot show. I guess kind of the best way to think about that is, let's grab purple. If you think about this length right here, it's flat. That is actually talking about this right here. That is taking that up, kind of like with that cone where you just kind of open it up and it will look something like that. So that's what we got going on here. We got that opening up and we have the circle. Well, let's start with the easy part. What's the area of the circle? Well, circle should hopefully be our easy part. Circle is pi r squared. That'd be pi times 9 squared, which is going to equal 81 pi centimeters squared. That's the easy part. Now let's talk about the cone. Now, the problem with the cone is there's no really nice, I'm going to apply like the square thing to it. I'm going to apply a circle to it. It's going to have its own formula to it. And that formula is going to be pi r L. Pi r L. That is the area of a cone. Area of a cone. But what exactly does that pi RL kind of stand for? So let's start with the R. R is your radius. R is just going to be your radius. So you find that radius of that circle. So in this case, we have a radius circle 9. So that R is just going to be 9. Now that L actually stands for length. What is the length? And what I want to point out is that 24 that runs along this side. So if we look at, let's pick a new color, orange. If I look at that length right here, that matches this length right here. So those are both 24. Well, that 24 will then be your length. Pi times radius times length of your cone. That will be the area of the cone. So area of cone equals pi r L, where r is the radius, L is the length. So it's pi times 9 times 24. So in this case, the area of the cone is going to be 216 pi centimeters squared. So our surface area is just going to be 81 pi. Plus that 216 pi, which equals 297 pi centimeters squared. So that's our surface area. A surface area is just going to be that circle plus the area of that cone that goes around it. Once again, we're not filling anything up. We're just looking for how do I paint the outside of the cone, how do I paint that circle. Last big example is determine the surface area of a regular hexagonal pyramid. Now, the difference between a pyramid and, let's go back to our prism. A prism has that polygon on the bottom, and it also has a polygon, same size, same shape, on top. A pyramid, just like the pyramids in like Cairo, is they're going to come to a point. We start with a polygon on the bottom. That polygon is going to be determined by that word. Hexagonal means that we're going to have 6 sides, and it's going to come to a point. Well, the nice thing about a pyramid is we're going to have one polygon and a bunch of triangles. This hexagonal will actually tell you how many triangles we have. We have a 6-sided shape on the bottom, so we're going to have 6 triangles. And if you look at the net shape, we have 1, 2, 3, 4, 5, 6 triangles, and we have 1 polygon. So our goal is to find our polygon and our 6 triangles. So those are the two shapes. We have a triangle, and we're going to have some kind of a polygon. The good thing is this tells us everything we need. This tells us our polygon and how many triangles we have. So once again, we have one hexagon, and we're going to have 6 triangles. Let's find our 6 triangles first. So 6 triangles. Just remember that's going to be 6. I'll change that to red so we know that the 6 comes from 6 triangles times the area of a triangle. Remember, area of a triangle is half base times height. Now be careful with this height. So we just got to be really careful about what is our base and what is our height. In this one, I didn't try to make it too tricky. We have that 26 there, which is going to be the base of every single triangle. So if we look here, we could go ahead and we could put a 26 here if we wanted to see that on the triangle. Now the height is going to be this 43. So I really didn't try to trick you on this one, but there will be ones, if you can kind of picture in your head, I might show you the height of the entire pyramid, which would look something like that. Note that that height, that red thing I just drew, is not the height of the triangle, that's the height of the pyramid. Now, noting that if I connected this, we would have a 90-degree angle, and we could potentially find the height that way. So be careful of what height I'm talking about, and look at your picture and ask questions if you're not sure which one is the height of the triangle or the height of the pyramid. So we should have all this information. So we're going to have 6 times 1/2. Well, 6 times 1/2 is just 3, so it really is 3 times my base times my height. Base is going to be a 26 times our height. Our height is going to be 43. Cool. So that means we're just going to have to do 6 times 1/2 times 26 times 43, which should come out to 3,354 centimeters. And it would be centimeters squared because it is the area of the 6 triangles. Now the last thing I need to find, so I have 6 triangles, I just need to find one hexagon. Now just a reminder, the area of any polygon is going to be 1/2 the apothem times the perimeter. And just a reminder, perimeter is, your number of sides times your length of your sides. Times kind of our length of sides. So we just need those 3 bits of information. We need the apothem, we need the number of sides, and we need the length. Well, the good thing is we have the length of each side. That is that 26. The length of that is 26. I also noted that there. So we have the number of sides is 26. And I'm sorry, we have the length is 26, but the number of sides, it's a hexagon. It's got 6 sides. So we have 6 times the length. So we already have a big chunk of this. We have 1/2 times the apothem times our perimeter, which would be the number of sides, which is 6, times the length of it, which would be 26. So we need to find the apothem. And that really is the hard part of this particular problem. And that is to find the apothem of a 6-sided figure. So let's go ahead and draw a 6-sided figure. So we got this hexagon going here, and let's look at what we want to find. We want to find the apothem. Let's call that there, my apothem. Well, we don't have that information. What we really only have is this 26. But I do want to specify that, when we can't find something, generally we're drawing triangles to find it. So let's draw a big triangle. Which means I'm going to split that 26 up into a 13 and 13. Now our goal is hopefully that this is a 30, 60, 90 triangle, which is going to turn out to be in order to, or 45, 45, 90, I guess, to actually find that particular triangle. Well, just as a reminder, an easy way to figure out the size of this is to think about this angle of this big triangle. Well, all the way around is 360 degrees. Divided by our number of sides, which would be 6, would give us 60 degrees. So that big angle right here, that whole angle is going to be 60 degrees. So since we have that big 60-degree angle, we're going to break it apart into two triangles. And we're just going to focus on one of the triangles, and that's this one right here. Let's draw it the best way I can. That was dashed. This is going to be 13. This is a right angle. This is my apothem. All right. So since that big angle right here was 6 degrees, that's going to make this angle right here 30 degrees, which makes this our 60 degrees. So this is a 30, 60, 90 triangle where we would have kind of, I know people don't like when I use S, so let's use X to stand for that one. So the one across from our 60 degrees is going to be our X square root of 3. In other words, since X is 13, this is going to be 13 square root of 3. That is my apothem length. So we can go ahead and throw that in our apothem length. So we have that 13 square root of 3. Now remember, we're going to try to keep things with the square root in it. So I'm really going to do 6 times 26 times 13 times that 1/2. Keeping that square root of 3 is going to give me 1014 square root of 3 centimeters squared. So that's going to give me a surface area. I'm going to go ahead and put this in parentheses. That would be that 3354 plus the hexagon centimeters squared. Now remember, these parentheses are just so I don't have to write that centimeters squared twice. I'm saying everything is centimeters squared. All right, that is our surface area. I will stress once again, keep things organized. Let me know that you're finding 6 triangles. Let me know you're finding 1 hexagon. That way, if you make a mistake, I know what it is, and I know where to find that mistake so I can give you appropriate points. If I don't know what you're doing, you're going to lose a lot of points if you just have some random answer down here. Keep things organized, draw pictures as best you can, and you'll get the maximum amount of points. All right, below are just the different types of solids, and we already talked about some of these in class for the most part. Primarily, I just want to be able to say something and you kind of know what the shape looks like. So if I'm talking about a prism, all prisms are going to have a polygon on bottom and top. If I say something about a pyramid, it's going to have a point on the top. So anytime I say like hexagonal prism, you're thinking about a hexagon on bottom and top. If I say, a decagonal prism, that means 10 sides on the bottom, 10 sides on top. When we go to a pyramid, that means there's a point on top. When I'm talking about a cylinder, that means there's a circle on top and bottom. When there's a cone, we're talking about a circle on bottom. So cylinder, cone are dealing with circles. Prisms, pyramid deal with a polygon. Here are just some random assortment of names right here as well, classifying polyhedron shapes. That is just our prisms and our pyramids. All right, that is it for right now. Good luck on the homework. Take your time, organize stuff as best as possible. Once again, organize, organize, organize. That way I can give you the most amount of points when we do have a test on this. All right, guys, good luck. Remember, if you have questions, please ask.